Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello, greeting from Semarang, Indonesia. My name is Muhammad Khosyi'in. I will present my paper with the title Test Measurement of UHF RFID for Autonomous Vehicle Navigation. This paper is the result of our research study on autonomous vehicle, which began with a review of the navigation system in autonomous vehicle on my previous article with the title Review and Design of GPS RFID Localization for Autonomous Vehicle Navigation. And now our progress continue with the research of UHF RFID testing in navigation system for know the performance of the technology of RFID. This article provides a discussion of the testing and measurement of UHF RFID with the distance and facing angle parameter on static and moving state condition. So let's start our presentation with the introduction. We know that the vehicle navigation system is one of the most important systems on the autonomous vehicle. Navigation is needed in order to autonomous vehicle can drive on the track independently, can drive itself without the driver. Navigation is needed in order to autonomous vehicle can drive with itself on the track by using sensor and specific algorithm. The use of GPS, the common sensor in the navigation, the use of GPS independently has shortcoming related to accuracy. So in the GPS navigation system, vehicle navigation route based on coordinate need to be corrected. This is the problem of the GPS sensor, the accuracy. This correction can be done by adding another sensor. The integration of GPS and RFID technology can become a solution of this problem. We know that the RFID technology has several advantages besides being cost effectivity. An autonomous vehicle navigation system can be implemented by combining RFID reader data reading on RFID tags that installed in roadside with the navigation algorithm, with the data from GPS sensor. We combine the data from the reading of reader RFID and the data from GPS for getting localization or getting position. With some method, we combine this data to get the most accurate location or position. From this explanation, a problem arises related to the performance of UHF RFID technology, including which type of RFID tag can be used for the autonomous vehicle and how to install the RFID reader to get the most optimal reading area when use a sensor that expected to improve the GPS accuracy. Some related work, research related to the measurement of UHF RFID is very minimal resources, very minimal reference. RFID testing to obtain tag performance can be carried out by varying in addition to the angle and the frequency. We can change the angle and the frequency to get performance of RFID reader. And the RFID reader read ring is quite wide, this is up to 40 degrees from the normal reader line. And the reader response is still well read at speed of 60 km per hour. So we continue with the design of the experiment system. We have a procedure of test measurement of USF RFID. From the flowchart, we know that we begin with the initial observation. Yeah, we start from observation, review literature, and make a design testing. Yeah. We need some hardware and software. We begin with the set M distance testing. Yeah. There is M and N parameter or variable. M is the distance, yeah, from 1 to 8 meter, because from the dataset of RFID reader we know that the range can be read from this RFID reader from 6 until 8 meter. Yeah. And this is the performance of RFID reader. And we set on M distance testing and change RFID tag until 3 type of RFID tag. We put N RFID tag testing and replace every tag after finish on N RFID tag, yeah, until 3 tag, and change the distance. After replace 3 tag RFID, we change the distance until 8 meter, from 1 meter, 2 meter until 8 meter. So if we have a good precision, we continue with analysis. But if we have bad precision, we try to returning from the M distance testing to continue the experiment. On our measurement test, this is a schematic diagram. I use USF RFID reader electron type, and I use 3 type of RFID tag. Yeah. The first USF RFID tag card type. The second is passive metal tag, and the third is label sticker paper tag. Yeah, paper label sticker tag. I use laptop for processing data, and laser distance measuring to measure the distance from the RFID reader to tag RFID, and several other supporting device. Yeah. I use some software, software tool for processing this experiment, USF reader demo software to get the data from RFID reader reading to the tag. And the system testing, yeah, there are 2 methods of RFID testing. The first is static state condition, and the second is on the moving state condition. If this method is explained that the test and measurement result, the testing, the performance of RFID reader reading on several type of RFID tag is our research, our experiment is placed on campus yard, with checking the distance of RFID tag from the RFID reader. We use a total of 5 RFID tag on each type RFID. Yeah. So if I have a 3 tag type, every tag type, yeah, tag RFID card, passive metal tag, and label sticker tag, each of them we use 5 RFID tag. So many tag we try to test. The duration of RFID reader reading time is 5 seconds, with a frequency setting of 933 28 megahertz, yeah, and reading interval setting is 50 millisecond. The experiment result, I want to describe. The first method, RFID testing on the state. Yeah. This is the illustration of mounting an RFID reader rotating on the Z-axis. So the next is with Y-axis, rotating on Y-axis. If I describe with my hand, rotate of the RFID reader, this one, yeah, is example of the RFID reader. I want to rotate on Z-axis, yeah, this one, yeah. This is rotate on the -10 angle degree, and this one is rotate on Y-axis, and this one is on X-axis. And our experiment is use the Z-axis and Y-axis. Yeah. This is the illustration, and this is the result from tabel measurement. We know that on the reading, and on the reading tag RFID on the axis, rotate on the axis Z, yeah, with an angle -10. We know the result is not very good, but if I rotate on the Z-axis with the angle of 0 degree, the result is very good. Yeah. You know that the best position on Z-axis is on the 0 degree. And the next is on Y-axis. Yeah. On Y-axis, we rotate on the positive degree and the negative degree, and our result, yeah, can show on the picture. Yeah. The first picture, the result is that the type of cut tag RFID, yeah, the type of cut tag RFID is 60 to 80 times at a distance of 1 until 4 meters with an angle -45 to +45 degree. We can show you on the green color on the surface graph. This is measurement has a precision level on 98.92%. And the second picture on RFID reader reading on the Y-axis for the metal tag. The illustration of this picture, the characteristic of the RFID passive tag can be read effectively at a distance of 1 until 6 meters with the reading of 60 to 80 times at the angle of -60 degree to +60 degree. The best number of reading, to 100 time reading, and is still possible at a distance of 4 meters at an angle of 0 degree. And the next, on label sticker, the result is the highest number of the reading at 60 to 80 times with a distance 1 until 5 meters at the angle of -30 degree to +30 degree. This test has a precision of 98.87% Sorry. The next is the RFID testing on moving state condition. This is the illustration. Yeah. We put tag on the vehicle and move on several speed, and the result on RFID testing in the moving state condition, we know from this tabel, there is 3 tabel, yeah, and we get the best result is on the RFID cut tag type B, or on the metal tag RFID. Yeah, this is the result. Yeah. We know that on the moving state condition, on metal tag type, yeah, we is still read well at speed of 60 km/h, and the conclusion of our research, the best position of the RFID reader is facing toward on 0 degree for the Z-axis rotate and Y-axis, and the RFID tag that has the best accuracy is the type of USF RFID passive metal tag, or tag RFID type B. Still has a reading at distance of 4 meters as the best reading distance, and it has a reading angle of 90 degree. Our test has validation of the reading result of the 3 type of RFID tag on the test measurement of the static state condition, average precision level of 98.89%, and in the test on moving state condition have 98.52%. Thank you. This is my presentation. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.